Hello. What's up, guys? Making sure some things here. Hello. What's up, guys? 1 second. Okay. I think we're good. What's up, guys? Welcome back. Another day. Some more problems. Let's jump straight into it. Two problems we got today. See what we got. We looked at this problem yesterday. Did they not give us a new problem of the day? I don't know, but we solved this yesterday, so not gonna look at that. Let's take a look at our top 100 most liked. Study plan, top 100 most liked. Take a look, do some backtracking problems today. Take a look at some of these. Reset this. Let's take a look at some of these problems. Trying to think here. We probably want to start with so given a string containing digits from 2 to 9 inclusive. This is a classic problem. I feel like we've looked at this before, but given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Turn the answer in any order. I'm mapping in the digits to letters just like on the telephone button. This is given below. Note that one does not make up any letters. So let's jump up a drawing here. Take a look. Kind of think about how we want to approach this problem. So obviously this is a backtracking problem. I mean, it was in the backtracking section, so we already know this backtracking problem. What we want to do is think about how we can solve this problem. So I'm thinking here, I mean, straight away I kind of think of a hash map, right? Just mapping. Looks like 1 is, yeah, note that 1 does not map to any letters, right? So we don't need to do that. So obviously we want to create a hash map with each of our numbers, right? Being our key. Our numbers being our key and ABC being our value, right? So we go, I can't even draw a 3 now. Oh my gosh, dude, I cannot draw a 3. 3, D, E, F, right? Then we got a 4. And we look at G, H, I. Right, I'm not going to draw out all of them, but, you know, I'm sure you guys probably understand, right? We want to make a hash map, right? I'm just going to write hashy up here. Hashy, right? We look at a hash map, and I think to myself, okay, well, probably going to have a backtracking function, right? And inside of this backtracking function, probably want to have a for loop, right? That probably loops between all of these values, right? Or loops between the number that we're given, right? In this case, we get 23, so loops between 23. If it sees a 2, it adds whatever value and then backtracks after, right? So we would add the value. So we're going to do dot .a for dot append. We're going to dot append. Then we're going to call our backtracking function probably. And then I think we're just going to pop after. And I think that should work. I think that's the brute force solution here for this problem, I would think. Take a look at some discussion. I'm not sure, but I was just in an interview, solved for the first in the interview itself. I got hired. Let's go, dude. TCS, congrats, what company, bro? White people. Okay, so I think the way that we want to look at this problem is obviously we want to probably get a, because I don't want to write this myself. Let's do phone map for 2 through 9. Grab that from over here. Let's grab a phone map here. Make this a dictionary. Call it my dictionary because that's what I'm kind of used to. Fix this kind of indenting a little bit. Move this over. So we've got our dictionary here. Now we probably want to make our backtracking function. So let's do backtrack, def backtrack. Want to pass in a I and probably a current. All right, up here we, oh, what did I do here? up here, we probably want to make a res array, define a res array, right? Because we're returning a list, right? Inside of this backtrack function, we probably want to do, probably go for, let's do for num in MySQL dictionary, digits I. Okay, so what do? We're looping through each digit here, right? Depending on what our I is or what we're given here. Our I here, 23. Right? Let's see here. Oh shit. I gotta fix the way I'm sitting. For num in my dictionary digits I. What do we say we want to do here? So probably need a base case, low key, right? Inside of our base case, we probably want to look at, well, we want to check if the length of cur is equal to the length of our digits, right? Because if they both reach each other, then we know that this is a valid case, right? Because really we're only looking for stuff that's the same length as digits, right? Right, we have a length of 1 here, and all our answers are a length of 1, right? So if the answers are a length of 1, then we know that it works, right? So then we can instantly return, right? So we would probably do res.append cur.copy, and then we can have a return function here underneath it. Oh, get rid of that space. Let's return here. Right, and then we have our for loop here, right, that we loop through all the numbers now. So what we want to do here is we probably want to append to cur, right? Append our digits I. Not our digits I, sorry. We want to append, we're looping through our digits I, so we want to append our num. We cur.append our num, and then this is where we want to call our backtracking function. Backtrack, we want to call I plus 1 and pass in our cur, whatever our cur is at. And then this is our backtracking part here where we pop. So I believe we don't really need to return anything. Outside here, we can call our backtracking function. Backtrack, starting off at 0, and then passing in an empty string. And then we would simply just return our res. So let's see what that gives us here. Okay, so we got something. We got an incorrect answer. We got EDAE. Looks like this is right. BD. I don't think it matters about the order, right? Note that one does not matter. Return the answer in any order. So the order doesn't matter. So I think this looks good here. What I think here is that I think .copy is for copy for lists. I think it might be for lists, right? Built-in list, copy to copy a list, right? So, and I think that's why we're getting a list here in our answer. So probably what we want to do here is probably want to res.append. Probably want to join, since it is currently a list, we want to join it together as a string. So dot join, and then we pass in our digits, dot join cur, I think. Come through here, we return our res. Okay, so that worked. Now we need to deal with our empty case here. So our empty case would be, well, if not digits, we just want to return our empty string. And I believe that should be our, there we go. That was a pretty good problem. Simple backtracking problem. Damn, that was pretty good. Let's take a look at something different. Let's take a look at, we'll do one more backtracking problem. Let's take a look at permutations. Because why not? There's some simple backtracking. Just make sure we have the fundamentals. I feel like that's important. Given an array nums of distinct integers, return all possible permutations. You can return the answer in any order. So we're given a nums. We're given an output of the permutations. An array of nums of distinct integers return all the possible permutations. You can return the answer in any order. So, permutation. The way we want to think about this: 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So again here, we probably want to do a base case here. If not nums, we want to return the empty string. Otherwise, we probably want to define a backtracking function. Inside of this backtracking function, we want an I and probably a cur, kind of the same way we looked at the last one. But instead here, instead of looping through it, how can we generate these parentheses? These permutations, right? So, well, we know, again, like we know from this problem here that we can return when the length of it is the same as nums, right? So I think our base case will probably most likely be the same, right? So we check, okay, well, if the length of nums is equal to the length of, if the, let's start with length of cur is equal to the length of nums, then we probably know we need to append, right? So we would res.append. We want to append a list of a list. So here we probably want to append a .copy, which is a shallow copy of that thing. We can have our return statement here. I believe this should be our base case, right? After our base case in this recursive function, we probably want to do, I think it'd probably be the same kind of outline as the phone combinations one. I think we're going to need a for loop here. Probably looping between each of these, looping over all of these numbers, right? So we can go, we have an I here, maybe not. We can go, maybe not, maybe we don't need a for loop here, I'm thinking. Not a for, because we have an I, so we have an I that can access this number, right? We add this I, then maybe we can backtrack, go here, go here. But what if we want to start at 3? So maybe somehow, I'm trying to think here. What is the best way to look at this problem? Maybe I think we're gonna need a for loop. Maybe some sort of flag, maybe I'm thinking. I think, yeah, maybe, I think the way is a for loop, I would think, for num in range length nums. Right, I feel like we're gonna need some, let's call it flag. We can make an array with times by the length of nums. Right, so we're making an array called flag that holds all false. It holds, a bunch of values that are false, right? The way we can think about this is what I'm thinking here. Let's remove all this garbage. What I'm thinking here is that, so we have our array. So for this test case here, we have an array 1, 2, 3, right? We have our array 1, 2, 3. And what we want to do here is we have our array flag, right? We can leave it up here, flag. And I'm going to initialize it with f being false, right? Our Boolean variable false, right? So maybe there's some way that we can use this to check, right? So we loop through each number, right? For num and range length nums. Okay. And we check. We have our 4. We check. Is it there? Is the number there? Or is it false? Right? If it's false, then we can add that number. And when we add that number, then we mark it as true, right? We would mark this as true. And we would keep for looping through until we have all of the numbers, right? So what I'm thinking here is that inside of this for loop here, we can do, well, if flag num is false, then we can add that number, right? Then we would go flag num is equal to true. We add the number, cur.append. And we want to append our cur.append. We want to append our trying to think here. Cur.append what? Our nums of I, or nums of num. Then we probably want to call our backtracking function. Probably want to backtrack here. Backtrack to I. Backtrack. Do we always want to backtrack I though? Maybe we don't even need I. Do we need I? Maybe we need our flag and our cur. We loop with our for loop. We check if it's false. If it is, we make it we make it equal to true. We append nums. We backtrack probably with cur. So with our flag and cur. Would this work though? If it's false, flag num is equal to true. Cur.append nums is not. Backtrack with the flag and cur. I think that might work. We return. So we got res.append here, so we don't really need to return anything. Come outside this, we can call our first one, right? So passing our flag, our cur is here. We return res. Let's see what this gives us here, because I'm not sure. Res is not defined. I didn't define our res. Res is equal to an array here. Okay, we're missing something here. Output is 1, 2, 3. But we're not backtracking at all. That's what we're missing here. We're not backtracking. We have to backtrack here. Code.pop. Right, we don't need to call it again because then we come through the for loop again and we backtrack again as well. So I think that's what we're missing here. We're just missing our code.pop. Okay, no. Flag is equal to false. Flag number is equal to true. We would append. But if we pop, then we technically have to make flag num equal to false. Right? Or else it won't work. There we go. Woo! That was a good problem. Good way to solve it. Good thinking. Pretty happy with that. So feeling good about some backtracking problems. Maybe we can take a look at something maybe a little tougher. Take a look at Alright, let's just take a look at this one, because why not? Given m times n grid of characters board and a string word, return true if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. So we have our board here, right? With all our letters, and our word is A, B, C, C, E, D. We get true. So we're checking pretty much if this word, A, B, C, C, E, D, is inside here. So I guess the way that we want to think about this problem is, again, obviously we know it's a backtracking problem, right? So where would we want to start? Well, we'd have to start wherever A is, right? So, I mean, I think it's a normal problem, the way that we want to kind of look at it. Again, I'm no professional, but if I was to draw this out, man, I hate drawing on this, dude. This is so tough. We got our B here. We have our C. We have our E. And then we got S, F, C, S, A, D, E, and E. Let's make our graph here so we can visualize it a little better. Switch our color here. Whoops. So what we want to do here, right? The way I'm thinking about this is we probably want to loop through this array, right? Find our initial starting point. In this case, we have A here, which is in the first column here. But I think what we want to do here is we want to use a double for loop and obviously loop through our grid. Find our initial starting point, right? A is our initial starting point. And obviously we want to backtrack from here. So we would have a directions array. We would... Can we just run BFS on this though? Depth first search. Matrix string backtracking. So I think maybe the reason why I've solved this problem is I maybe ran BFS on this or DFS or something, but if I'm thinking about it in a backtracking way, how would we solve this using backtracking? I feel like for me, the fundamental way to solve this is probably run a DFS or a BFS on this using a directions array. But I'm wondering, is that probably the best way to do it? Is that running BFS? Alright, we can move here. Because really all we have to check down and right. Because really, or left, technically, right? We can't go diagonal. So let's take a look. Let's do word 0 is equal to temp. Let's print temp. Sorry. Temp is equal to word 0. Can you do that in a string? CDA. I feel like we probably... rows is equal to row, coal is equal to coal, rows is equal to row, rows is equal to the length of board, coals is equal to the length of board, 0. We loop through for row and rows for coal and coals, and we check, okay, well, if board row coal equal to 0, then equal to temp, would row coal, why do we have a double thing here? This is not, would row coal is equal to temp, then we can call our BFS, right? Or our DFS, whatever you want to call it, right? Let's do DFS here, because I feel like we do BFS all the time. So let's do DFS. We call our DFS function, pass in our row, our call, probably a visited, and yeah, let's do a visited, and directions. Probably want to do a directions array. Directions is equal to let's think about this. We go up, down, right, left. Right, so up, down, right, left would be 1. No, up. Up would be 1. Positive, no, negative. Negative 1, 0. Down would be positive 1, 0. Right would be 1, 0 here. And then our left will be negative 1, 0. We use this double for, we check, run DFS, right? We want to make our DFS function here, def DFS. We pass in our RC. Probably want a visited array, right? So I guess we can, probably don't want to define that because there could be multiple of these, right? We could be looking at multiple starting points, right? And if we are looking at multiple starting points, we probably want to pass in a set like this, right? So I want to call this probably visited, and then we have our directions array, right? We loop through this and we go, okay, well, I'm thinking, do we do iterative DFS here? Is that a possibility here when we're running DFS? Never really done that, but I'm trying to think. What are the ways that we can think about this problem? Well, we start off, we know that this is the value. If our next value is not B, or the second point in our array, so how are we going to keep track of that? We would probably have to keep track with an I too, I feel like, right? So I feel like we'd probably need an index value too to do this. Probably need an index value. Directions, index. In this case here, we always know to pass in 0, right? feel like the recursive way to solve this problem is let's do that because I'm kind of used to that. Base case is here. Our base case for this problem would be, okay, guess we do if the length of word minus 1 is equal to index. No. Hey bro, ACC. Hey bro, ACC TU is love real. I don't know what that means, bro. Ariane. Hey bro, ACC TU is love real. Love is real, dude. That's all I got from that question. If you could kind of clarify a little bit, I'm not sure what you mean by that, but we want to check if the length of the word is minus 1 is equal to index, because then we know we're at the last value. Well, what if we did if the length of word maybe it should be if the length of word is equal to index, right? Because if you think about it, we get the length of this word. The length of this word is 1, 2, 3, 4, 5, 6. ACC meant, hey bro, according to you, is love real? Oh. According. Yeah, dude. I think so. Do you believe in love, bro? I believe it's real. So what do you think, Ariane? So here, the reason why I say that is we check, okay, if the length of word is equal to index, and we have 1, 2, 3, 4, 5, 6, right? And we're starting with our index is 0. Once we get to 6, because then we find that value, right? And then we pass in plus 1 on the index value, then we're going to be checking if the length of that is equal to the end, which would we actually run into probably an out of bounds here, because technically, technically, like, we're past our word count. We're past our word, right? Good to see you, just lurking. Yo, what's up, Tom? Appreciate it, dude. Appreciate you watching, bro. Did we check the length of the word is equal to index? And it's out of bounds. So I think here, if we find that, then according to this problem, this is where we'd probably want to return true, right? Otherwise, the way that we would want to return false would be, well, if the current word that we're looking at, right? So we could go, okay, well, if word index does not equal, wait, no. If grid R C does not equal grid RC does not equal index, does not equal, sorry, this has to be word index, then we instantly know that we can return false here, right? And then the recursive part here, if you probably want to loop through and we go, okay, well, for NR, NC indirections, probably want to make a new row here, which is equal to NR plus our current R that we're at. New call is equal to NC plus C. then we want to check our bounds here, right? So if, as long as it's in bounds, 0 is less than or equal to new row, but is less than rows, and 0 is less than or equal to new col, but is less than cols, and we're not in visited, and new row, new col, not in visited, you return false. And it's not in visited, right? So if we're not in visited, then here we can call our DFS function, right? Pass in our new row, new col, and also our visited array, visited index. I feel like we need a path as well now that I think about it. Let's add our path here, visited, and then we have an index. So we would probably need a, oh shit, we're missing something. We need a path here, visited, directions, and then an index, right? Here our path, I guess our path could be a set as well. Doesn't really matter. So we go set, directions, and then our index, right? We loop through here, we check the bounds. Obviously we're gonna have to add to our visited set first, so then we go new row, new col. Add this as a value here. DFS new row, new col, path, visited, directions, index, right? Instead here, we're gonna have to up, right, to +1. So if we return this, right, if this comes as true, how do we have to deal with that? So if this comes back from our DFS function as true, or sorry, technically we're looping here, so maybe we should be checking if it's false. If not DFS, this comes back as false. I'm kind of stuck. I think love is just hormonal attraction. We feel. I had a crush on many girls, and a girl who had a crush on me, and I came to know about that 2 years ago. I still regret not making her my girlfriend. She was pretty. That's good, man. Had a crush on many girls, a girl had a crush on me. Man, you should have, dude. You should have asked her to be your girlfriend, bro. I do believe in love, though, Ariane. I do believe in love. I believe it does exist. You gotta find the right person, though, because I feel like it can also go south as well. So, so I'm kind of stuck here, and I'm trying to think, if we were to return false here, what would we do? I feel like we're thinking about it in the wrong way. Maybe this isn't the way to think about it. I think I could easily solve this using BFS. I mean, I feel like maybe, let's see. How did I solve this? April 17th, December 22nd. It's been a while. Keep grinding, brother. Appreciate that, Abhishek. Appreciate that, bro. Thank you. I'm thinking of using DFS here. What is wrong? Grid is not defined. You should be using board. Well, that's obvious. Where am I using grid here? This should be board. I think board, yeah. So we have over here, we have -1. We've got repeated values here. This should be a y value. This should be a y value here. We have x values here. We need our range function. We can't have rows by itself or calls by itself. Hi Max, I think you probably already answered this question, but how do you organize your thoughts when you're solving LeetCode problems? How do I organize my thoughts? That's a good question, dude. Either I plan it out here on a drawing board and I think about how I'm going to solve this. Usually I kind of keep going, bro. You are my example. Haha. I appreciate that, Bruno, dude. That's really kind of you. Thank you, bro. How kind of I do my thoughts? To be honest, I'm looking at this problem, right, Bruno? And I have solved this problem before. You know, I solved it a few months ago. To be honest, I solved it a few months ago and I don't even remember how I solved it. I'd have to look back. I probably solved this either using BFS or I maybe solved it using backtracking or whatever. Right now, I'm kind of thinking of a DFS solution. The way I kind of think about it is I kind of have the intuition from past problems I've done. So I kind of, just from the amount of problems I've done, I kind of get the experience of the patterns. The one thing I think I'm at my level that I'm at is that I can identify like how to solve the problem and the way I want to solve the problem. But the thing is with me is that I kind of struggle kind of translating that into code sometimes, like thinking of like it programming. Like you think of this right now, like I'm running DFS on this and I feel like I'm thinking about it properly, but definitely what helps with me is kind of planning it out on this board the way I'm thinking about it. But other than that, that's kind of all I do. I just kind of mess around with it. And just kind of have that intuition. I feel like the intuition is the most important thing, but I'm sorry if that kind of doesn't really answer your question, but I think I sort of did, but keep going, keep solving it though, bro. Like really all you need is just the experience, bro. Just like spend an hour every day and just do some problems, like revisit problems, do new problems. Like I think revisiting is also really important because like sometimes, I don't know, maybe other people are different, but for me, when I'm doing these problems, sometimes I kind of, you know, a couple days ago, I was looking at some sliding window problems and I just like really struggled with the sliding window problems and I couldn't do it. You know, I had solved it before a couple months ago and I couldn't do it. So, you know, just the thinking of it is just really important. Going back to problems is the most important thing as well. Ariane says, at the time, I thought I need to be financially independent to take care of her and my family is still not financially well, so I thought I should not be a burden to her. Yeah, bro. I definitely agree with that, bro. I definitely agree with that. It's right, man. There's plenty of people out in the world, bro. So I'm sure you'll meet new people too. So, nice to hear your answer and make sense. Okay, I appreciate that made sense, bro. How's your stuff going, Bruno? Are you looking for a job too, or are you, what are you up to? You have a job? Are you a student? I can't remember. I've seen you before on the stream. I just, I don't really remember. I don't know if I've asked you, so. But I do remember your name. Appreciate you stopping by too, bro. Makes it more fun doing these problems. So I'm trying to think here how I'm thinking about this problem. So here they're just using a row column, a index, and a visited. So I feel like I'm kind of overthinking this here. Maybe we keep our visited. I guess we don't really need to pass in our directions array. Yo, Ethan, dude. Nice to see you, bro. Very insightful, Max. Keep up the great work. I love you, Ethan, dude. Appreciate you. Kind of got me started on this, bro. You inspired me, so I appreciate you. Thank you so much, dude. So I'm thinking here, we check if the length of the word is equal to index, we want to return true. If board row column does not equal word index, new row, new column, directions. Currently work at a large bank in Brazil as an iOS engineer. That's cool, Bruno, dude. That's awesome, dude. I'm happy for you. In the beginning of the month, I didn't pass the Uber interview. Ah, man, I'm sorry, bro. That sucks, dude. It's tough out there. I've never had an interview of that level yet, so I don't know. I don't even know if I'm kind of ready to pass those. I probably wouldn't pass it either. I don't know. I get kind of nervous, bro, like when I jump on those. Like, I feel like if I was in the middle of an interview and I jumped on it, dude, I would probably shit my pants, dude, if I had to, you know, program in front of someone like that. Like, I'd probably mess it up. So I don't know. We'll see. That depends if I can even get an interview with Uber, dude. That's the tough part. So props to you for actually getting the interview. New row, new call. Not unvisited. What am I missing here? So maybe instead of checking here, we can check this inside of here. If new row or we go or 0. Sicko Warmy, hello from Denmark, dude. What's up, bro? How you doing, man? So if we do, okay, well, if or r is less than 0 or r is greater than or equal to rows, or c is less than 0 or c is greater than or equal to cols. We want to return false. I think we also have to check the visited here, so we would have to go, well, and you would pass by Uber, bro. I got the binary tree exercise, and I kind of got nervous and couldn't think of anything, but it happens. Yeah, bro, that for sure, dude. I mean, I do the same thing, Bruno. Like, I'd probably get nervous too, bro. I always get nervous in front of people, and it's tough, dude. So, especially someone like, you know, probably knows way more than me as well. So, what distro is this? I'm using Linux Mint, bro. Do you use what distro do you use, Sicko? Probably want to check if RC invisited too. Then we want to return false, right? So now instead of looking at the bounds here, we can go here, pass in our new row, new call, get rid of our path. KCOS. Oh, okay, I use Arch KCOS. That's cool, man. I don't know, dude. I don't know if I could switch to Arch yet, bro. Nothing's broke on my machine yet, so I'm happy that I don't want to deal with things breaking all the time. I feel like that's probably awful to figure out. Got our visited array here. So visited, get rid of our directions, increase our index by 1. So so if it's false, we just want to return false and do nothing with it, right? But if it's true, then we probably want to return true. Come outside of here. KCO OS is nice for AMD machines, nice improvements in gaming. Running about 17% higher FPS in Stellar Blade, that on Windows 11, and less stutters. Course precision shaders. That's cool, dude. I'm the most basic Linux dude. I'm not a Linux bro or anything. I literally just switched a couple months ago, so I think Linux Mint is pretty chill for me. So I never tried Mint. Yeah, it's good, dude. I enjoy it. At least it's been good for me for like someone new to Linux. So it's been it's been good. So. Oh, we probably want to remove our visited out here. Visited.remove. A new row, new col. Probably return false. I used Linux for 1 year now. I really like it. Yeah, it is great, dude. I really like it too. It's probably one of my favorites too. So here, now we probably want to add a return function down here. Let's return. So if the length of word is equal to index, we want to return true, but we're expecting. I guess we can return false outside of here, but if this returns true, then we can return true to our function completely, or to our program here. Takes, oh, well, we got too many. Get rid of this directions, get rid of this, get rid of this. Move this shit over here. We need more parentheses around this. I think this makes sense. I think key error 00, new row, new column. Oh, I think we're gonna have to remove row here. Oh, sorry. What do we call that out here? RC. So what are you making here? This is just LeetCode, bro. Like, to be honest, it's kind of really it's just like a platform where you can get ready for interviews and stuff like that. Just like DSA problems and stuff like that. I'm not really building or making anything, but I'm just working on these problems, trying to learn and stuff like that. So what are we getting here? We're getting a key error here. Why are we getting a key error though? Because I think this isn't inside of it. So maybe this has to go. Will this have to go inside? So if we're looping through the directions array, making a new row and a new call, check if DFS is in our bounds. If this returns true, so if it's true, it jumps into our next one. Where are we adding visited? We're not adding visited anywhere. I feel like that's what we're missing. We're not adding. I think that's why it's not working. Visited.add. Row in a column. I think this needs to go outside now. Because I thought it would go outside. List index is out of range. List index is out of range. What do you do, Sicko, bro? Do you you work full time or anything, or what do you do? Return false. Linux is out of range. Why am I getting? I have to check this before. That's why. I think the bounds have to be checked first, and then can check it here. Okay, we're getting somewhere. Here we go. Okay. So it ran. We passed a couple test cases. EBCE, SFCS, ADEE, ABCB. Expected false, but we got true. Why are we getting true here? A, B, C. Oh, wait, what's that word? That word is ABCB. ABC. So somehow I think it must be coming back here, and that's why it's returning true. So I visited. I think there's a problem with that visited array. We have a visited.add here. We add our row column. We add it. We loop through the directions array. Create our new row and a new column. We call our defs function. Right? We call our defs function. It comes up here. If it's false, it doesn't work. But if it's true, then it keeps going. It adds the next one. Then goes through here. Right? Again. Returns true. Gets this. Returns true. I think there's something with the recursive calls, maybe. I don't know. Can anyone see what my bug is here? Because I don't know what it is. If anyone in the chat can see or understands, I'm honestly not sure what my bug is here. New row, new column, visited. Fast using visited if board row call does not equal word index. I don't know what it is. I don't know what my bug is. What is my bug? The conditional logic groupings due to the lack of parentheses, specifically the conditions. Oh. So there was nothing wrong with my code, it's these parentheses. Apparently is what's wrong. I didn't really think about that, to be honest. Is that what it is? Row is equal to this. Okay, no. So if shouldn't this be, maybe this should be an OR. Maybe that's my issue. Maybe it should be an OR here. Okay, well that is not. Now it's breaking. Why is it not running now, dude? What's going on here? It's crazy, dude. Test result. Great. My fucking website has crashed. What is going on here, dude? Dude, literally think my website just crashed. Dude, oh my gosh, dude. What the hell? What problem were we looking at, dude? I don't even... Google Chrome. Force quit, dude. Jeez, my computer's crashing, dude. What is going on here? Bro, what the hell? No way, dude. My computer's crashing, bro. Oh my gosh, dude. How do you force quit, dude? Does anyone know how to force quit on Linux, dude? I'm not sure off the top of my head. Dude, what is going on here, dude? Oh my god, bro. What is going on right now, dude? I have to look up how to force quit, dude. Hang on, dude. I gotta look this up, dude. Oh my gosh, bro. So frustrating. I'll do force quit in. I can't remember the commands, dude. Oh my gosh, dude. What is going on here? Bro, dude. Dude, what is going on right now, bro? My computer's literally frozen, bro. Jeez. Man, what an L, dude. Oh, dude. Where's Chrome, dude? What the fuck? Jeez, man. Bro, what is going on right now? Alright, guys. I might have to come back. I think I'm gonna have to restart my computer, so that's kind of an L. Xkill. If you use Xkill, you can force quit any application you click on. It's like the window. Oh, there we go. Appreciate that, Ethan, dude. Thank you. Thank you for that. How long has it been since you've graduated with a master's degree? I'm still in school, Diego. Sorry, bro. I wasn't looking at the chat. There we go. Thank you for that, Ethan. I couldn't do that, dude. I've never had that happen to me before. Now I can't even open Chrome, dude. W Ethan. Yeah, W Ethan, dude. What a legend. Now Chrome won't even open on my computer, dude. What is going on here? Is anything gonna open? Jeez, dude. Of course, man. Ethan, you know why my stuff isn't opening, dude? Why Chrome isn't opening? How can I debug this, dude? Can't even get my browser open, bro. You know how to? You got any help, dude? What is going on right now, dude? What is this? Google. Can you do PS minus AUX Chrome? PS minus AUX Google? You can check if Chrome is fully quit with PS aux grep Chrome. Is that the command PS aux grep? So we've got Chrome here. And use pkill -9 Chrome. pkill -9 Chrome. Do I have to use the ID number here? Is it pkill like 7842? Is that how it works? No. You know how to, you know anything here, Ethan? I use these, right? These IDs here, but I'm not sure, bro, honestly, like. Default Chrome, dude. PS kill 7849. Pkill 7849. Okay, well it's still there. Crash pad. Dude, honestly, I'm kind of lost, dude. I don't know how to. Dude, I don't even know what is going on with my computer. I think I might have to restart my computer. That's so awkward, dude. Jeez. That's why Chrome sucks. Don't use Chrome. I would just restart, lol. That's my limit of Linux knowledge. Yeah, bro, I don't know much either. I think I'm going to quickly restart my computer and I'll probably jump the stream back on. -9 is a SIG kill flag. Yeah, I think I got to restart my computer, dude. I'm not sure. I think that's what I'm going to do, and then I'll put the stream back up, but probably keep streaming for about another hour or so. So I think I'm going to restart my computer. I'll be back in a second.